Alright, and welcome to Absolute Value, Level 4. Now, in our very first example, you're going to notice that what makes this a level 4 problem, is that our absolute value is no longer equal to a single term. And in fact, we would say now it is equivalent to an expression. Now, if I had to reconcile this some way graphically, my best intuition would be that this would be some sort of, I'm just kind of making this up, but we have some sort of absolute value, and now we essentially more or less have a line intersecting it potentially at 2 points. Okay, that would be my best representation of it as of right now. Now, what does this really imply to us? Well, we're trying to find out where the absolute value of 4x minus 8 is equal to the expression 2x plus 6, but this leads us to an interesting question. Much like in our previous levels, is this actually equal to a negative 2x plus 6, or is it equivalent to a positive 2x plus 6, where that whole quantity is either negative or that whole quantity is either positive? But remember, the absolute value bars are making it appear to be positive in the end. So how do we reconcile this? Well, what we're going to do is we're going to take our original absolute value, 4x minus 8, and we will set it equal to both the negative version of 2x plus 6, and we'll take that 4x minus 8 and set it equal to the positive version of 2x plus 6. Now, in the positive version, I don't need to put it all in parentheses and put a negative. However, in the negative version, I do need to put everything inside a negative parentheses, because what that is telling us is that that negative will in fact distribute. So now I have 4x minus 8 is equal to, this negative distributes to be a negative 2x and a negative 6. Okay, now from here, I'm simply going to solve it as we typically would. So we'll move our smaller x, so I'll add 2x to both sides. And this will give you 4x plus 2x is 6x minus 8 is equal to negative 6. Now real quick, just for spatial reasoning here, we can go ahead and say, well, then we have 6x minus, 6x minus 8 is equal to negative 6x. We'll then add 8 to both sides, and we'll get 6x is equal to negative 6 plus 8, which, let's see, that would be 2, and then we'll divide both sides by 6. And we can say that x is equal to 1 over 3 once we reduce that. Now let me go ahead and just kind of jot this over here. Our very first potential solution is x is equal to 1 over 3. Now I encourage y'all to pause this, finish taking these notes, and let me kind of clean this up for our second solution. Okay, and so now we're setting the 4x minus 8 equal to the positive expression of 2x plus 8, and here we'll still move our smaller x, so minus 2x, and of course 4x minus 2x is 2x. Minus 8 is equal to 6. Well, now to get rid of a negative 8, we're going to add 8 to both sides, and that cancels, and we get 2x is equal to 6 plus 8, which is 14. Now, of course, guys, 2x equals 14. We want to divide both sides by 2, and we get x is equal to 7, which brings us to our second potential solution. Now, I want you to pause this, and I want you to finish, these notes right here, and let me clear this up to go on to the final part of this problem. Okay, here's the problem with absolute value when set equal to an expression. The problem is you might sometimes have what's called an extraneous solution. An extraneous solution is a solution that works out mathematically but doesn't actually, it's not actually technically correct. So in the answer choices, I have only set it so that you solve for your two solutions and you're done. Or I should say your two potential solutions and you're done. But how would you find the extraneous solution? Well, you go back to your original problem, and you actually have to plug in. Your solutions and see if they actually work out, just to make sure that they are in fact actual solutions. So you won't have to do this on today's assignment, but just understand that this is sometimes a part of the thing, or a part of the process. So here we have 4 times 1/3, which is 4/3 minus 8, and I'll begin to turn that into 8 over 1, is equal to 2 times 1/3 is 2 over 3 plus 6, and I'll begin to turn that into 6 over 1. Now, if I want to add these fractions, I need a common denominator, so 1 times 3 will get me a common denominator here, and of course the same is true, 1 times 3 will get me a common denominator here. If you're a little bit confused with the fraction work, I would highly encourage you to go YouTube how to add or subtract fractions, and you'll get a myriad number of videos. Well, 8 times 3 is 24 over 1 times 3 is 3 is equal to 2 over 3 plus 6 times 3 is 18 over 1 times 3 is 3. And now we have this. We have the absolute value of 4 minus 24, which will be negative 20 over 3, is equal to 2 plus 18 is 20 over 3. And if I were to ask you, is this a true or false statement? Well, I would hope you would say true, because remember, absolute value bars make everything positive, so this is really saying positive 20 over 3 is equal to positive 20 over 3, and that does in fact check out. So 1/3 is really and truly a good solution. Let me pause this and clear it up as we test out our second solution. Okay, so let's go ahead and test out our 7, our second possible solution. Okay, and let's see, let's go ahead and plug in 7 right there and 7 right there, and let's work it down. We see we have the absolute value of 4 times 7 is 28 minus 8 is equal to 2 times 7, which is 14 plus 6. 28 minus 8 is in fact 20, so we have the absolute value of 20 is equal to 20. And of course, guys, the absolute value keep things positive, and so this is really saying 20 is equal to 20. So we're in luck, both of these solutions checked out. And if I were telling you how to reconcile this, what would I really be saying? Well, let me go ahead and clear this up real quick. More or less, guys, I would be saying something like this. I'd be saying, hey, you know what? We have some sort of absolute value. All right, it's not going to shift off the x-axis, I don't believe. And our expression 2x plus 6 is really saying something like, you know what? This thing is going to cross here at like this x value of 1/3, and this is going to cross right over here at this x value of 7. And this is what we're saying in this equation. Okay, let's move on to our second example. Okay, in example 2, we have the absolute value of 5x minus 7 is equal to negative 3x plus 8. Now notice something, our 3 is negative, but it's not the only term here. Since it's not the only term, we can't just immediately write this off as no solution. So let's go ahead and say this. We really don't know, like if I was you, how would I solve these moving forward? We don't know if the 5x minus 7 is equal to the positive version or the negative version of negative 3x plus 8. And so we are going to essentially take whatever we see in our absolute value, which is this 5x minus 7, and we are going to set it equal to both versions of the negative 3x plus 8. So over here to the right, I'll set it equal to the negative version of negative 3x plus 8, and I'll set it equal to the positive version of negative 3x plus 8. Now remember, guys, the negative version, you always have to write all of the expression in parentheses with a negative in front of it. However, for the positive version, you'll just write it as you see it. Okay, so let's go ahead and work this down. We have 5x minus 7 is equal to, a negative times a negative is a positive, and a negative times a positive is a negative. And from here, we'll just move our smaller x. So minus 3x, and we get 5x minus 3x is 2x minus 7 equals negative 8. Now from here, of course, we can add 7 to both sides, and we get 2x is equal to negative 1. And after I divide both sides by 2, I get my very first solution, x is equal to negative 1 over 2. Okay, now let's go ahead and look at our example on the right where we had our positive solution. So the first thing I do is I move my smaller x. I add 3x to both sides, and that goes away. We have 5x plus 3x, which is 8x minus 7 is equal to 8. Now, how do we get rid of a minus 7? Well, we will add 7 to both sides. That goes away. And we have 8x is equal to 8 plus 7, which is 15. And I'll divide both sides by 8. We'll say x is equal to 15 over 8. Now, as y'all finish writing down that example on the right, let me just kind of clean this up over here so I can write this new solution. And we have x is equal to 15 over 8. Now, remember, in the problems that I'm giving you, this would be where you would stop. You would say, okay, I found my two potential solutions, and we're going to stop right there. However, I want to show you how you find your potentially extraneous solution. Okay, so let's go ahead and let's try out our very first one, this negative 1/2. Just kind of give this a little color. We'll say we have the absolute value of 5x minus 7 is equal to negative 3x plus 8. Okay, and what's this going to look like? Well, our very first solution is negative 1 over 2, negative 1 over 2, and now we have to simplify both sides and see if this is actually correct. Okay, so this is really negative 5 over 2. Remember, it's 5 over 1, and when I do the top, 5 times 1 is 5, and 1 times 2 is 2, minus 7. And I'll go ahead and put that over 1, is equal to, over here, a negative times negative is a positive 3 over 2. And negative 3 times 8 is negative 24, which I will also begin to put over 1. My apologies, over 1. Now from here, in order to add or combine these fractions, I need to get a common denominator. I know that 1 times 2 is 2, so I multiply the top and bottom by 2. And over here, 1 times 2 is also 2. And what is this going to give me? Well, it'll give me negative 5 over 2 minus 7 times 2 is 14 over 1 times 2 is 2 is equal to 3 over 2 minus 24 times 2 is 48 over 2. And let's see what we get. Okay, so negative 5 minus 14 is negative 19 over 2 is equal to 3 over 2 minus 48 over 2 is negative 45 over 2. And lastly, guys, the absolute value of negative 19 over 2 is positive 19 over 2 equals negative 45 over 2. That is wrong. That is false. That is not a solution. In fact, we would say this. We would say x equals negative 1 over 2 is extraneous. That's an O. Is extraneous. It means it works out mathematically, but it is not actually a solution. Let me go ahead and clear this up for y'all real quick. Okay, now we're going to go ahead and test out our second solution. So we can do 5x minus 7 is equal to negative 3x plus 8, where our second solution is 15 over 8. That's kind of a nasty fraction, but I think it's going to be okay. Okay, so we go ahead and do some multiplication. 5 times 15 is 75. The further you get into mathematics, the more frequently that one pops up. All right, minus 7, and I'll go ahead and put it over 1 is equal to negative 3 times 15 over 8 is negative 45 over 8 plus 8 over 1. Now to go ahead and make my fractions have a common denominator, I'll multiply this one right here by 8, the top and bottom by 8, and I'll multiply this one by 8 over 8. And let's see what we get. Well, here we get 75 over 8 minus 7 times 8 is going to be 56 over 8, absolute value, equals, and let's see, we'll have negative 45 over 8 plus 8 times 8 is 64 over 8. And this is looking kind of promising. Let's see, 75 minus 56 appears to me that it would be a 19. I could be wrong, but we'll see. Okay, 19 over 8, absolute value, is equal to, and negative 45 plus 64 would also appear to be 19 over 8. Now the absolute value of 19 over 8 is 19 over 8 equals 19 over 8. And yes, this is in fact our solution. Now how would you reconcile this graphically? Let me clear this up for y'all just real quick. Okay, My best understanding is essentially, I'm going to kind of start with our linear function here. Notice this is our linear function, negative 3x plus 8. So 1, 2, 3, 4, 5, 6, 7, 8. Here's 8. And if I go down 1, 2, 3 into the right 1, and I go down 1, 2, 3 into the right 1, I'm essentially going to have some sort of line like that. Okay? And if my solution is 15 over 8, which is really 1 and 7/8, we can kind of think of it as like going, okay, you know, here is 1, here is 2. More or less, what I think you could essentially say is that this graph, this line, is only touching our absolute value function in one place. So it appears to me it might be something like, let's see, our absolute value function of the absolute value of 5x minus 7 might be something like this, where this side will never cross our linear function, and we have this one solution right here. Okie doke. Alright guys, I hope this helps. I know this is a longer video, but you know, it's a more complex problem. It needs a little bit more attention to detail. Good luck on this section, and I'll see you guys in our next video.